Good morning. Today we are going to continue drawing covalent compounds. All right. So we're going to check the two that you were assigned yesterday. First one we had is NH3, nitrogen trihydride. So let's go ahead and let's start by drawing the correct number of nitrogens. So the subscript for nitrogen is a 1. So that means I'm drawing 1 nitrogen. It's in group 15, so therefore it has 5 valence electrons. Now, here is the subscript for hydrogen, it's 3. So some people are like, all right, here I go, there's my hydrogen with 3. That's definitely incorrect. So what you have to do is you have 3 hydrogens, and each hydrogen has 1 valence electron because hydrogen is in group 1. Now, let the diagram do the work for you. So there is a bonding. Let the diagram help you. Let the diagram do the work for you. So hydrogen is never going to be what we call a central molecule. Things don't bond around hydrogen because it only has 1 bonding site. But nitrogen, on the other hand, it needs a bond here, it needs a bond here, and it needs a bond here. So it needs 3 bonds, and it just so happens that we have 3 hydrogens. So this hydrogen is gonna, and it doesn't matter where you draw the lines, this guy could bond here, 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 all right? Or, this one could bond here, here, here. It doesn't matter where they go because this is a 3-dimensional molecule. So you're going to turn it in space. So here's nitrogen with its 5, and this is the cleanup part of the diagram. It's bonded to this hydrogen. There's one of the 3. Here's another, and here is another. So this is what the molecule ammonia looks like. So to write down like the stats about ammonia, there are 1, 2, 3 single bonds because 1 bond exists between each element. And over here, there's 1 unshared pair. Okay, so here is the unshared pair. Nitrogen is not stable because it has 1, 2, 3, sharing 4, 5, sharing 6, 7, sharing 8. So nitrogen is not stable. And this is how polyatomic ions form. All right, and so down here we have Br2. All right, so the subscript tells me that I'm going to draw how many Brs? I'm going to draw 2. Bromine is in group 17, so it has 7 valence electrons. A skill that you already have. You should already be able to draw valence electrons. Okay, now let the diagram do the work. The number of bonds it needs is going to be determined by the number of spaces that it has left open. So there's nothing here and there's nothing here. They each need 1. So they're going to form a single bond. So what I do, this is kind of like my workspace on this side, and this is the cleaned up version over here. So in the cleaned up version, I'm going to draw the rest of the valence electrons. So in analyzing this molecule, sorry, I'm trying to make that a little more visible. In analyzing this molecule of bromine, I have one single bond. Okay, so I connected those two dots. Remember, there's a valence electron here, and there's a valence electron here. And the reason it's a covalent bond is they're sharing the valency right here. And how many unshared pairs? Well, there's a lot. There's 1, 2, 3, 4, 5, 6. There's 6 unshared pairs. And remember from yesterday, unshared pairs do have a job. Unshared pairs determine the shape of the molecule. Okay, so that's checking yesterday's work. Getting into today's new content, we're going to work with double and triple bonds and other different types of molecules, and maybe we might throw some singles in there. The good thing about this is that there aren't that many examples I can do before I have to repeat an element. So you're going to see some of these a lot. So example 1 would be O2. Okay. So this is what we call a diatomic molecule because it just exists as itself twice. If you were to name it, I would name it dioxide. And so I'm going to draw 2 oxygens based on the subscript. Find oxygen on the periodic table. It's in group 16. So there are 6 valence electrons. All right. Now, take a look at each oxygen. This oxygen over here on the left, it needs an electron here, and it needs an electron here. The oxygen atom on the right needs one here and one here. They both need 2. This is different than bromine. Each bromine only needed 1. So these guys need 2. So therefore, they're going to form not a single bond, but I'm going to connect both lines. All right, and I'm going to clean it up. So how many lines did I draw between them? 1, 2. And the reason that I do the cleanup diagram is because these bonds, they don't bend, all right? So this right here would never happen in real life, but it has to happen here because I can't physically pick up a valence electron and move it. All right, so I drew the 2 lines right here, is here and here. All right, now I have a pair here and a pair here. Doesn't matter where you put them, as long as they're paired up. Okay, so let's talk about this molecule. This one is called one double bond. Okay, one double bond exists right here. Now, I drew the unshared pairs of electrons kind of off to the sides because these electrons have negative charges. They're all the same charge. What do same charges do? They repel. So they want to be as far away from each other as possible. Would you know that drawing it? No. Do you know it now? Yeah. Am I going to mark it wrong if you draw them together? No. So with these unshared pairs, there's 1, 2, 3, 4. There's 4 unshared pairs. So let the molecule do the work for you. Like, look at what it needs. If it needs 2 and the other one needs 2, it's probably going to form a double bond. Okay. The next one that we're going to do is P2. P2 is diphosphide. So I have 2 phosphorus molecules. Okay, when you find where phosphorus is on the periodic table, it's in group 15, so therefore it has 5. Okay. All right, so now you drew your 2 phosphorus with the 5, it has 5 valence electrons. So now take a look at each one and think about, well, what does each need to become stable? Well, this phosphorus needs 1, 2, 3. This guy also needs 3. So where are they going to get those 3 from? Well, since they each need 3, they're going to form not a single bond, not a double bond, but they're going to form a triple bond. What? So they're going to form a triple bond. So what we're going to do is we're going to clean up the drawing. So I drew 3 lines connecting them because they each needed 1, 2, 3. So those are the 3. And here are some unshared pairs of electrons. Sorry, Tom keeps bugging me to let him draw some Lego figures on here for you. Maybe someday I'll let Tom teach the lesson. It could be highly entertaining. So what we have up here is we have a triple bond. So we have 1 triple bond. And how many unshared pairs? 1, 2. Okay, so there are 2 unshared pairs. And that's today's lesson. Let the diagram do the work for you. It's like a puzzle. If they both need 1, it's going to be a single bond. If they both need 2, it's going to be a double. If they both need 3, it's going to be a triple. So I'm going to give you guys some to practice. All right, example 3, let's do S2. Example 4, let's do N2. Let's see how good some of you are. Example 5, let's do CO2. I'm going to put a little hint here. Carbon is a central molecule or central element. That's not molecule. Which means that carbon likes to be the center of attention. So everything is going to bond around carbon. So see if you can figure that one out. Try these 3, and then tomorrow's video I will start by going over these. Thanks.